All right, here is the test review for one-dimensional motion. We're talking about constant motion. Number 1, 2 and 3, we need to match the variables with their proper base unit. So there are a lot of units that we can use to measure things like speed, velocity, distance, time. But in physics, we're going to use metric units. We are going to use meters per second to measure speed or velocity. And we're going to use meters to measure distance or displacement. We're going to use seconds to measure time. Number 4, the distance and direction something is from a reference point. This is just a definition. Distance and direction is referring to the displacement of that object. So displacement is a straight line path back to where you started. It's a short line or straight line back to the beginning. Apparently I can't spell displacement. There we go. Okay. Number 5. There's 3 scalar quantities we've learned so far. Well, scalar meaning no direction, just a magnitude, just a number. We've talked about distance. We've talked about speed and time. 2 vector quantities. So vectors have direction. Let me add that back over here in number 5. These have no direction. And vector quantities have direction. Okay? So 2 vector quantities that we've learned so far are the only 2 variables that we've talked about that are not listed, and it's displacement and velocity. Number 7, vector quantities do have direction, just like we said, and can be negative. So negatives indicate direction. They can indicate downward movement or movement to the left. Negatives can be used to determine direction. Okay. Number 8, fill in the blank. So distance, the distance that someone travels depends on the path that you take. So the more pathways you take, the more or increased distance I have because I'm adding up all the pathways. So we would say that distance is path dependent. And displacement is always in relation to where you started. So it doesn't matter how many different pathways you take. It's always just more important where you end, because the displacement is how far are you from where you started. So we would say these are, our displacement is path independent. Now, there is no difference in magnitude between distance and displacement on a straight trip. So anytime, if I start here at A and I travel here to B, if, let's say for example, from A to B is 2 meters, then I traveled a distance of 2 meters. If I ended at B, the shortest pathway back to A is also 2 meters. So in this case, there is no difference between distance and displacement on a straight trip. However, the only difference between distance and displacement on a straight trip is direction. And lastly, on this side, scalars are always equal in magnitude to vectors when the objects move in one direction. But if the object moves in different directions, my distance increases and increases. So at that point, my scalars become greater than my vectors because displacement is a vector and it's the shortest distance back to where I started. So that pathway will always be shorter than my distance. All right, on the next page here. Number 10, what is the only way to be sure a car has constant velocity if the speedometer reads a constant speed of 60 miles per hour? Well, if I'm looking at my speedometer, it's telling me 60 miles an hour. It's just giving me a number. So there's no direction associated with it, which is why it's a scalar. But in order to have a velocity, I need to know direction. So you need to be going in one direction while reading 60 miles per hour. All right, number 11. What four parts of a car are used to influence velocity? Okay, well, the brake pedal is one. The brake, the gas will certainly change your velocity. They'll cause you to speed up or slow down. If I turn the steering wheel, okay, I'm changing direction. Velocity has direction. And if I change the gear shift, if I put it in drive, if I put it in reverse, okay, I'm changing direction there. So these four have an influence on velocity. The two that are also used to influence speed would be brake and gas. You're going faster, you go slower. Number 12, Maria walks 15 meters north, turns and walks 2 meters west at a steady speed of 2 meters per second. How long does it take Maria to reach her destination? Well, Maria is doing this. She's walking north 2 meters, and then 15 meters. And then she's turning and walking west 2 meters. Okay? I want to know how long it takes her to walk that far. So your keywords, how long, is asking you for time. So it's asking you to figure out or determine the time it takes her to reach her destination. Okay? Up here, it tells me her speed is 2 meters per second. So speed is 2 meters per second. Last thing I'm missing here is distance. Well, it told me she walked 15 meters north, 2 meters west. So to find her distance, I simply just add them up. 15 plus 2 gives me 17. So her distance is 17 meters. So using my equation, speed equals distance divided by time, I'm going to plug in for speed 2. Distance, we said was 17. And time is unknown. So I got time as part of my denominator on the right. It's part of a fraction. I need to make a fraction on the left. In order to do that, I'm going to put 2 over 1. And now all I have to do is cross multiply. So if I cross multiply 2 times the t and 1 times the 17, that'll set me up for my next step. So 2 times t is 2t. And then 1 times 17 is 17. Now my last step is getting t by itself. T is being multiplied by 2, so the opposite is to divide by 2. And you'll notice that on this side, 2's cancel out, and that gives me t by itself. So I have t by itself. Now whatever I do on one side, I've got to do to the other side. So if I divide by 2 on the left, I've got to divide by 2 on the right. And I get 17 divided by 2, which comes out to be 8.5. 8.5 seconds. All right, looking up at number 13. 13 plays off of number 12. And I'm going to redraw the path that Maria took. She went north 15 meters and then west 2 meters. It's asking me for her displacement. How far is she from where she started? Well, if she started here and ended here, her displacement is a straight line path back. And what you notice is that we form a right triangle. And I need to find side C by using Pythagorean theorem. So let's say side A is 15, side B is 2, and C is unknown. Pythagorean theorem says that 15 squared plus 2 squared equals C squared. So 15 squared plus 2 squared gives me 229. And in order to get C by itself, my last step to get rid of that square is to take the square root of both sides. And I get C all alone. And the square root of C, the square root of 229 is 15.13 meters. That is her displacement. Number 14. What is the displacement of a grasshopper that jumped 15 meters north, 13 meters east, 12 meters south, 13 meters west, 18 meters north? Okay. Let's draw this out. So 15 meters north, and then 13 meters east, and then 12 meters south, 13 meters west, and then 18 meters north. So that overlaps my line that I already drew there, so I'm going to change the color here a little bit. And 18 meters north goes back up this way. Okay? I need to figure out their displacement, which is how far they are from where they started. So if the grasshopper ended here and started here, how far is that? Well, if from here to here, this initial line is 15 meters. This part on this side is 12, then that means this little segment down here has to be 3. So from here to here is 3 meters. If from here all the way to the top here is 18 meters, then I am a full 18 meters plus an additional 3 meters from where I started, and 18 plus 3 gives me 21. 21 meters is the displacement of that grasshopper. Now, what is the distance that the grasshopper jumped? This is the easy one because all you have to do is add them up. It first went 15 meters, and then 13 meters, and then 12 meters, and then 13 again, and then 18, and 15 plus 13 plus 12 plus 13 plus 18 gives me 71 meters as the grasshopper's distance. Okay, backside. We have this jet plane that flew 800 kilometers in 2 hours and then turned west and flies 2,000 kilometers in 4 hours. So I'm looking at a path of 800 kilometers in 2 hours, and it's flying west 2,000 kilometers in 4 hours. I need to know the magnitude of the velocity for the first 2 hours. So it only wants to know the velocity during this section, during the first 2 hours. Okay, well, how do I find velocity? Velocity is displacement over time. After 2 hours, at this point, I am 800 kilometers away from where I started. So my displacement from here is 800. and the time it took me to get here is 2 hours. So 800 divided by 2 gives me 400 kilometers per hour. Number 17, calculate the average speed for the entire trip. So speed is distance divided by time. So the entire distance is 800 plus 2,000, which comes out to 2,800. And the total time it took is 2 hours plus 4 hours, which gives me 6 hours. So 2,800 divided by 6 equals 466.67 kilometers per hour. Okay, number 18. How far will a car traveling at a constant rate of 30 meters per second go in 10 minutes? And it gives you seconds, 600 seconds. Well, so how far is asking you for distance or displacement. It says a constant rate of 30 meters per second. This is the velocity. And the time in seconds, that's t. So velocity equals distance over time, or displacement over time. My velocity is 30. Displacement is unknown. And the time is 600 seconds. Okay, so I've got d in the numerator. I need to solve for d. I've got it in a fraction. I need to make a fraction on the left. So I'll put 30 over 1 and cross multiply. 30 times 600 and 1 times d. So 30 times 600 gives me 18,000 equals, and then 1 times d is simply just 1d or d. So 18,000 is my distance, and that's in kilometers. Okay, moving forward. The slope in a distance versus time graph, also known as position versus time, represents, I'll change that color here, represents the velocity of that object. And the slope in a velocity versus time graph measures acceleration. Okay, so what do the slopes tell us? Well, positive slope in a distance versus time graph means the object is moving away. Positive slope means it's moving away. So a negative slope means it's moving towards. So down here I'm going to draw a distance versus time graph to show a constant negative velocity. So I'm going to set up a y and an x. This will be distance. This is time. The constant line is going to be a straight line. It's got a negative velocity. That's a negative slope. Something like that. Here I want to draw a velocity versus time graph walking forward at a constant speed. So I'm going to set up my y and my x. This is velocity. This is time. If it's walking forward, I know it's going to have a positive slope in my position versus time graph, which puts me in quadrant 1. And it's at a constant speed, so it's going to be a straight horizontal line, just like this. This is in a velocity versus time graph. And lastly, we've got this graph here. I need to calculate the velocity of the object at each segment. So segment A, segment B, C, and D. Okay, A has got a positive slope, so I can expect that to have a positive velocity. B has 0 slope, so this tells me it's not moving, so my velocity should be 0. C is a positive slope, which tells me it should be a positive velocity. And D is a negative slope, tells me it should have a negative velocity. So here's how you calculate velocity based off of the graph. Okay, velocity equals displacement divided by time. Also written as final distance minus initial distance divided by time. Okay? In segment A, I ended here, I started here. My initial distance is 0. My final distance is 12. So I get V equals 12 minus 0 divided by, and then the time from here to here is 1, 2 seconds. This little segment, if I follow it down, 2 seconds. Count the spaces. 1, 2. So 12 divided by 0 is 12. Divided by 2 is 6 meters per second. In segment B, we said it's a flat, horizontal, 0 slope. It's not moving. The velocity should be 0. Let's find out. Velocity equals my final position at the end of B is at 12. My starting position at B is also 12. So I end up with 12 minus 12. And how many seconds? Count the spaces. From here to here is 1. Here to here is 2. So 12 minus 12 is 0. Divided by 2 equals 0. So sure enough, 0 meters per second. In my third segment, C, it's got a positive slope. It should have a positive velocity. So we're looking at between here and here only. This little segment. Okay, so the velocity is equal to final distance minus initial distance. My initial distance started here is at 12. My final distance was here and it ended at 18. So 18 minus 12 divided by, count the spaces, 1 second, 2 seconds, 3 seconds. So 18 minus 12 gives me 6. Divided by 3 seconds gives me a velocity of 2 meters per second. And the last one is D. We said it's a negative slope, so it should have a negative velocity. Okay, so let's set it up. Velocity equals final position minus initial position. It started here at 18 and ended here at 10. So final position is 10. Initial position was at 18. Divided by, count the spaces, 1, 2 seconds. So 10 minus 18 is a negative 8. Divided by a positive 2 gives me a negative 4 meters per second. So describe the path traveled by the object being graphed. Well, segment A has a positive slope. So A is moving away. B had a 0 slope, so it's not moving. C had a positive slope, so it is also moving away. And D had a negative slope, it's moving towards.